Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, I'm going to show you another decision statement, the switch decision statement, and then we're going to talk about enumerations. And then I'm going to show you how the IDE, the Visual Studio IDE, helps you use the two in conjunction quite nicely. So if you recall from our discussion of the if statement back in lesson 7 or 8, we used a number of if and else if statements. So for example, if user value equals 1, then do this. Else if user value equals 2, then do that. Else if user value equals 3, and so on. All right. And honestly, that approach worked just fine. But generally, if you have a lot of potential values, you can write the same intent more succinctly by using the switch statement instead. So in that instance, in that example from lesson 7 or 8, we only had 3 cases. But what if we had 10 cases or 20 cases to check through? All right, we can write something more compact using the switch statement. So let's go ahead and create a new project called Using Switch. And so I'm going to write a lot of code here, so give me a moment, make sure you follow along. Okay, I'm guessing that you could probably easily figure out how this works without me walking through it. However, in a moment, I'm going to explain a couple of aspects in more detail. So let's see the results. First of all, I'm going to go ahead and type in green lantern, and it returns back to me the Emerald Knight. Okay. You'll notice that I typed out most of this. There is a code snippet that helps you create this more easily. You can go switch tab tab, and it creates the basic structure for you, and from that point on you can go user value and continue on from there. All right. Just to leave no stone unturned, we're going to evaluate the value of the variable user value that a user types in. So we see a very succinct syntax that allows us to evaluate, again, several known possibilities, Batman or Superman and so on. And then once we match whatever the user typed in, we can run any code block after the semicolon, and we then call the break statement to break out of the switch once we found the case that applies to our situation. So no additional evaluations are made after that. So what's the difference between the if statement and the switch statement? Well, in some situations it can improve the clarity of your code, especially when there are many possible values that require an evaluation. While the if statement can handle more complex situations, it's generally a bit verbose when you need to evaluate many possible scenarios like what we've done here. All right. But here's where the if statement really shines. Okay, so as you can see here off camera, I created another project called the complex if statement. This just demonstrates the complexity that you can express using the if decision statement that you cannot accomplish with the switch statement. So here I'm checking for either conditions, either this is true or this is true, using the OR operator. Here's another OR between, checking if this specific value or this range of values is true and so on, and I can use chain together multiple conditions and then be able to perform some result like a console.write line message. Okay, so using the switch, this isn't possible. But in my opinion, the switch statement is much cleaner to the eye whenever you're in this type of scenario where you're just evaluating against several known cases that you want to check against. Okay. Anyway, let's move on to enumerations because these ideas will dovetail together. Enumerations are basically a data type that allow only a small list of possible values. So enumerations constrain the data, forcing it to comply to be only one of several possibilities. And in so doing, it makes your code much more reliable. So generally speaking, comparing magic strings like I've done here, comparing whatever the user types in, like Batman, against a string called capital B-A-T-M-A-N is not a very reliable practice. And in fact, some would call it a bad programming practice. So in this example, we accounted for the possibility that the end user would type in Batman in all lowercase letters. Now, in this case, we used the toUpper method of the string type in order to ensure that we're comparing two strings so that we have a chance of these two to match regardless of whatever capitalization scheme the end user has or whatever I have. But what about the word Green Lantern? Is there a space between those two words or no space? Well, I suppose we could latch on another thing here like a trim, but that would only remove any space characters before or after. So I guess I could use a replace function to replace all spaces with nothing. You know, just basically remove all of the empty spaces from the entire string and then compare it against the various cases here. But pretty soon you're going to find just too many special cases, and so it's generally, again, not a good programming practice. And so that's why in the .NET Framework class library, the creators of the library, they force you to set property values equal to an enumeration. And you see them all over the place, and this prevents errors from occurring. So let's do this. I'm going to create another new project. Let's save what we've got here. And we're going to, this time, make sure it's console application. We're going to call this Understanding Enumerations. And what I want to do is just start off by showing you some of the enumerations that are available within the .NET Framework. So let's say, for example, that you want to set the foreground color of the console window. So I'll begin typing this line of code, console dot foreground color equals, and notice whenever I hit the space on the keyboard after the equal sign that IntelliSense pops up. It's automatically selecting the console color enumeration. So if I choose this and hit the period after the console color enumeration, it gives me a number of colors that I can choose from. So for example, I can choose dark red. All right. So in this case, you can see that I've been constrained to set the foreground color property to a specific data type called console color. And console color only has a few options to choose from. You saw that list of colors in alphabetical order. All right. So let's continue on with this code example, then we'll come back and show you how to build your own enumerations. And I just want to show you this in action. So let's go ahead and start the application, and you can see that I get the text, the foreground color of the text in that dark red color. All right, great. So the foreground color property is constrained to only offer viable colors. I can't just use a literal string, dark red, because the foreground color is not of type string. It is of type enum console color. Somewhere there's an enumeration defined called console color in the .NET Framework class library that defines all the possible color combinations allowed in the console. Again, the benefit to you, the developer, is that it forces you to pick the correct value, leading to higher quality code. You might misspell the literal string red, I don't know, and you might not catch that until runtime. However, using enumerations, the error would be caught at the time of compilation. That's kind of the definition of working with a strongly typed language like C#. So again, our goal here is to point out that sometimes you'll deal with properties in the .NET Framework class library that are of some enumeration type. Be aware of that and pay attention to the IntelliSense, which will guide you on what to do next. Okay. Now, having said that, let me show you how you can create your own custom enumerations in C# so that you can better understand how this works. And maybe someday you'll create your own custom enumerations for your own applications. All right. So let's do this. I'm going to do this outside of the class program. Enum superhero. And then I'm merely going to, inside of the code block, type the names, the values that this type, this enum, will make available. So let me comment out this line of code, and let me show you what happens when I attempt to actually use this enum. So superhero, my value, equals superhero. See how it popped it up for me there? And now I can choose one of these possible values. So now what I want to do is revisit that example that we created at the very outset when we were talking about switch statements. And I want to show you this cool way to work with both the switch statement and enums that Visual Studio kind of makes possible. All right, so here we go. So I'm going to use switch tab tab, and then I'm going to type in my value, enter, enter, and notice when I hit the second enter that it automatically used all of the enumerations that I defined. So that's a little bit of Visual Studio IDE magic that I was referring to a little bit later, where it will automatically create all the cases for the enumerations that you've defined. That's awesome. Okay, so let's continue on with this example here. I'm actually going to go above it, console. Okay, so before we're ready to go with this, we have a little bit of a challenge. What we need to do is get the string that the user typed in into a format that's that matches our enum, since that is what we're comparing it against. So superhero is not a string, it is a type unto itself. So we're going to need to perform a data conversion. And really the easiest way to do this is like so. So to perform that conversion, I'm going to do the following. If enum try parse of type superhero, we'll pass in the user value that we collected from the user. We're going to use this overloaded version where we tell it to ignore the case, true. And then if we're able to successfully parse user value into the type superhero just based on a string comparison, then we will output the new value into my value, the my value variable. All right, and I'm going to enclose this if statement around the switch, and when I do that, Visual Studio automatically indents the switch just a little bit. All right, so let's kind of clean things up here a little bit. Let's talk about this line of code in line number 21. We're trying to convert the string that the user types in with the name of one of our enums. This is hardly a foolproof approach, but it does demonstrate this enum.tryParse method. We're trying to parse a string into one of the enums of the superhero enum type. Batman, Superman, Green Lantern, all right? So that's why we have the data type in between the open and closing angle brackets. In C#, when you see the angle brackets, it's called a generic method. As you'll learn, you make a generic method specific by specifying a data type. Now, I'll talk more about generics in an upcoming lesson. Just know that for now, we're attempting to convert a string value that the user types in, the user value variable, into a superhero enum. So there's three parameters of the try parse method. The first is the string that we actually want to evaluate. That's the user value variable. The second parameter is whether we should ignore capitalization in the user value string, which we set to true. So we do want to ignore capitalization. Now the third parameter is tricky. It's an output parameter. An output parameter is like an input parameter, except it's sent from the method to the caller. All right, so how is this different from a return value of a method? So how is an output parameter any different from the return value? Well, look what happens here. Try parse will return either true or false. So if try parse is false, then try parse failed. But if it succeeds, it'll return true, and the parsed enum will be sent out via the output parameter. So you use an output parameter so that you can both communicate the success or failure of an operation as well as the result of the successful operation. So now that we know that try parse succeeded, we can expect my value, the output parameter, to contain a valid enum that we can then use in our switch statement below. All right, so let's finish this up. We have to tell it to do something here. Console.WriteLine. And we'll add an else here. Console.WriteLine does not compute. All right, because we know we don't have a match, so we'll hit the else statement and we'll print out to screen. And now let's try this. Let's type in Superman, Man of Steel. Let's try it one more time. Some such, and does not compute. All right, great. So what's the benefit here? Well, we're able to use enumerations and rely on the Visual Studio IDE's code snippet plus its lookup of the type that we're trying to switch against, and it explodes out all the possibilities. So now I just have to do the implementation for each of the cases. In this case, I just wrote one line of code at console.WriteLine. The other benefit is that I'm getting away from literal strings, and I can rely on the fact that whatever the user types in will match one of the enumerated values, and if it doesn't match, we can catch it. We can catch it here. All right. So we're not working again with unreliable magic strings. All right. So in this lesson, we talked about the switch statement. We looked at enumerations, especially those that we see in the .NET Framework class library. We then created our own enumeration just to kind of prove how it works, to show you how the IDE makes it easy to combine the switch statement with enumerations that you created using code snippets and some automation within the Visual Studio IDE. And we also saw how to use the enum.tryparse method. I intentionally skipped over the complex part. You might be wondering about these angle brackets. Well, I didn't really want to talk about the idea of generics just yet. Just know that you'll need to put the data type that you want to convert or try to parse your string into inside of those angle brackets. And we'll talk about generics in just a few lessons from now, and so we'll see you there. Thank you.